Welcome to Concrete, Pictorial and Abstract Materials at Early Level. Please pause the video to ensure you have Cuisenaire rods, Numicon, counters and a 10 frame ready. Please feel free to take photos of the activities rather than trying to remember what to do. Today's session will look at an introduction to the progression and guidance document at early level, a recap of CPA principles, and an introduction to Cuisenaire, Numicon and 5 and 10 frames. Hopefully you are all aware of the early level SPC Maths Progression and Guidance document and the trackers. In response to the development of the breakthrough curriculum and feedback from practitioners, these have been updated for August 24. They can be found at the bottom of the Maths and Numeracy page on the early level portal, as well as on the SBC Thing link. All ELK settings should be using the SBC tracker from August 24 as part of this breakthrough curriculum, so they should be coming up to you in P1 if they're not already doing so. The progression and guidance document should be used to support the planning of experiences, spaces and interactions in your class, as well as identifying learning and next steps. At the beginning of the progression document are the skills from the benchmarks. These are the skills that need to be developed all the way from ELK through to higher learning. These are in green on the progression document. Children need the secure foundation of these skills to progress in any number or maths work. They should not be taught in isolation, but through experiences in the interactions that we offer. The first one is interpreting questions. Learners need the understanding of the vocabulary we are using, and from our emerging literacy, we know that in order to acquire new vocabulary, a child needs 50 or more meaningful experiences around a word to learn it. They need to be able to select and communicate processes and solutions. Learners need to have numerous opportunities to explore a range of strategies and opportunities to talk about their thinking. They need to be able to justify their choice of strategy used. Once learners have been able to explore different strategies, they then need to be able to talk about why they have chosen that particular strategy and why it fits that particular piece of learning. They need to be able to link mathematical concepts. This is vital for learners' understanding and ability to problem solve. They need to be able to use mathematical vocabulary and notation. This is often an area which is the focus for early years, and whilst it's important, the other skills are just as important. Mental agility. Fluency with number facts comes from an understanding and repetition of experiences using real objects, pictorial representations, way before we start introducing abstract representations like numerals. Daily experiences using 5 and 10 frames and supertizing enable children to develop this mental agility. Reason algebraically. Can learners identify the missing quantity if they have a 10 frame with 8 counters in it? And finally, determining the reasonableness of a solution. This is so important for learners as they need to have the understanding that their answer is likely or unlikely to be correct. This involves being able to estimate and come to approximate answers in order to check if their answer is reasonable. As part of the updating process, we have added key vocabulary for practitioners and teachers to use with and to begin to develop with the children. The progression only has been coloured to show what a typical child in ELK 3 might achieve, that's in white, ELK 4, that's pale blue, and P1 is the darker blue. We have deliberately not put them into columns to show the holistic nature of how children develop their mathematical skills. They're not necessarily hierarchical. Down the side in green are the skills focuses, which can be developed through this organiser. The E and O is at the top of each section, and the photographs are just ideas and exemplars of the sort of things you might like to do. The statements in red are the benchmarks for early level. In italics are little pieces of extra advice to bear in mind, such as children find it much more difficult to understand the concept of less, as we tend to use the word more often. Guidance page numbers are given in red, and it's well worth reading the guidance notes before embarking on the E&O as part of your planning process. It may change the way that you think. Here you can see that there are hyperlinks to the YMI pages and other pages which will support you delivering this aspect. Children might not progress along each organiser step by step. They may achieve something further along the line, but may not understand the concepts before that. It is really important that they understand all of the little stepping stones. Especially with something like number, they could have learnt knowledge from home, but may not understand the why. For example, children say they can count to 20, age 3, but do they really understand the value of each number they say? Subitizing, finger patterns are all discussed in the guidance, and you will find information to help you develop this effectively with children. It includes extra reading as well. You will notice that the focus is on concrete apparatus rather than pictorial or abstract representations. The exemplar photos are of loose parts, outdoor learning, and mathematical equipment and resources. What is your understanding of CPA? What do you use already? Your first port of call should be loose parts, real items, or representations of items. Pause the video and discuss how you use CPA already in your maths experiences. There are representations of all three in photographs. Which of these, if any, do you use? All children with any new learning should be introduced to concepts using the concrete apparatus, then the pictorial, and then the abstract, right through their time in school or beyond. Possibly the apparatus you are least familiar with are the Cuisenaire rods. They were invented by Georges Cuisenaire, who was a Belgian teacher. He started his career teaching during World War I and in the 1940s founded his own school. It is believed he invented his rods after noticing his students were deeply engaged during a music class where they could do something with their hands, but lacked engagement in maths lessons where they listened passively and filled out worksheets. He designed the rods as a way to make maths more engaging and improve children's understanding at the same time. Some of your ELK may have Cuisenaire rods as a result of attending the EYT training, and the message for them is just for the children to play and explore with them. The ones shown here are maxi counting rods, and they are much thicker and chunkier for little hands. At the moment, it is difficult to get hold of them, but you might be able to get something similar if you search the internet. I found some on eBay. There are giant magnetic ones available, or Cozy even make giant outdoor ones. Pause the video and have a play with your Cuisenaire rods. Just have a play. Jot down anything you notice or anything you wonder. This can be done with children, and you can record their answers on post-it notes and discuss them later. It could well be used as a plenary. These are examples of children who've been exploring and playing with the Cuisenaire rods. What do you notice? What do you wonder? Did you notice that they had been designed as families? George Cuisenaire designed the rods in these families to try to enable the children to become familiar with numbers and especially the relationship between them. Put your Cuisenaire's rods into these families. The red family, the red, purple and brown, the green family, light green, dark green and blue, and the yellow family, yellow and orange. These can be assigned the values of the red family of 2, 4 and 8, the blue family of 3, 6 and 9, the yellow family of 5 and 10. Then you have the white and the black, which could be assigned 1 and 7. 1 has a relationship to all the other numbers, but 7 has a relationship to none. You'll have noticed that I say that you could attach a numerical value to them. We suggest that you do not attach a numerical value until the children have really explored and become familiar with the rods, and we suggest it from the end of P1 if your child is developmentally ready, but if not, they can be reintroduced in P2. Pause the video while you carry out these challenges. Discuss as a team the answers to the questions. Research says that the link between children's ability to spot patterns is more indicative of later mathematical achievement than their ability to count. It is vital that children understand that patterns are something which repeat and are able to verbalize this as well as what the pattern is. They may make patterns as part of their exploration and play using the Cuisenaire rod. They need experience of making a wide variety of patterns, and Cuisenaire rods lend themselves to this perfectly. Try to challenge the children to make patterns which are more complex than just yellow, blue, yellow, blue, yellow, blue. You might like to challenge them to make circular patterns or growing patterns. You might like to ask them to create a pattern using 3 types of rod longer than the yellow. Can they make patterns again, but making them with smaller than the yellow? Pause the video while you carry out the activity on the screen. Now explore the same rod, but with more than 2 rods to match the same length. Were there more combinations or fewer? Did you have the same colours, but in different places? Think about how children could record this. Could it be through photos, through drawings, through some sort of cut and stick activity? Again, we try not to attribute a numerical value to the rods, but say if this is an 8, then this is a 5 and a 2. But if this is a 16, then this is a 10 and a 2 and a 4. Pause the video while you explore these questions. Pause the video to carry out the task on the screen. Numicon is probably one of the most widely used concrete apparatus. You may be using it already and have done the Numicon training, or it may be something in a box in the back of a cupboard gathering dust. Most elks have a box, and we encourage them to use Numicon for exploration and playing. This was an elk child who discovered equivalence, putting different combinations of pieces on top to match. The Numicon set comes with baseboards, these overlays of pictures, and pegs. The children love trying to fill the board without any gaps. In doing so, they need to be able to rotate and turn over the shapes. Fitting the shapes back into the box can be a challenge. The bottom of the box actually has the shapes and the values on them. You could just allow the children to explore the Numicon with the baseboards and the pegs. You might add them to your painting table, or you could introduce scales to see what they discover. Numicon is actually weighted, so a 2 and a 4 will balance a 6. You could challenge them with something like the example in the tough tray. Limit the Numicon so the children have to problem solve which Numicon to use where in order to create all of the elves. Never get the children to count the holes with Numicon. Talk to the children about a 1 or a 5 or a 10. They need to become familiar with the values of the pieces. They need that visual image of the shape. Those of you who use Numicon, how have you done this? Pause the video whilst you have a go at what the instructions on the screen. Use your Numicon to make a Numicon staircase like the one in the picture. It's important to have the 2 horizontally and to have the odd one sticking up on the right each time so that it actually makes a staircase. You can play games with the staircase. It's important to develop the noticing skills and justification skills that prove it. How do you know? With your partner, one person shuts their eyes and the other swaps 2 pieces around. Can you identify what's been swapped? Again, the other person shuts their eyes and the other person takes one out. What's been removed? Have a go at the ideas on the screen. Again, what do you notice? What do you wonder? Look at the odds and evens in Numicon. Again, the colours have been chosen purposefully. Allow children time to explore how pegs fit into the holes of the Numicon and onto the board. The photo on the left was a child exploring 8 using the pegs and shapes. The pegs are a great way of supporting children's supertising. Here I can see a 3 and a 2 and a 2 and a 1. Also, you're obviously exploring more than 2 parts to make the whole, where the other is just 2 parts to a whole. The photo on the right was a specific challenge to use the shapes to create a shape which was equal to 10. Double-sided counters supported the understanding of a 5 and a 5 equaling 10. We know the link between children's ability to spot patterns is more indicative of later mathematical achievement than counting, as is good spatial awareness. Numicon is a very visual resource for creating and spotting patterns as well as developing spatial awareness skills. How do you think you could extend the child's learning with this pattern? Numicon here have been used alongside cubes to look at the different permutations of the numbers to 7. Pause the video whilst you have time to plan and experience using Numicon in your class. Five and 10 frames. How many of them have you used them already? Do you use them as flashcards with children supertising quantities up to 10, beyond? In ELK, we recommend children practicing supertising to at least 5 using a 5 and a 10 frame. This here is a video of ELK children actually using 5 frames. These are a tool to develop number sense and understanding, not counting. We never get children to count using a 5 or a 10 frame. They're great for developing number sense and understanding of number and applying knowledge, and they teach that instant visual recognition of how a number looks and the perceptual supertising, that arrangement of counters. When introducing 5 and 10 frames, start with a 5 frame. Ensure that the counters, dots, whatever you're using, have a low cognitive load. So that means they're the same size, same shape, same colour. So children focus on the quantity rather than the contents of the cell. Ensure children understand the concept of the frame being full and not full to begin with. Work systematically. from left to right or bottom to top. If a 5 frame becomes full, then put another 5 frame with it. The maximum is 2 5 frames to make a 10 frame. Never have 3 because we work in base 10. They can be used in a variety of practical concepts to support this perceptual subitizing. Here we can see they've been used as registration or for lunches. They're both in nurseries, but the children in P1 or beyond can use a similar setup so that instead of photographs, they have names on dots. They don't necessarily need a home, although this actually is great for using calculations. Children place their names on the 10 frame from left to right until full, talk about the quantity there and they're adding one more, and then can they give you the new total? Talk about the frame being full and the number of spaces until that frame is full. For this purpose, you do not want the children to be counting the squares nor the counters. And it's good practice to show that it doesn't matter if the 5 frame is horizontal or vertical, that it's still full or empty. This conservation of number, the idea of the same object shown in different way, still make the same total. You could then write the number of children present or having each colour of lunch, showing the 10 frame amount corresponding to the written numeral. Highlight the 10s and 1s being the same as the full 10 frames and the not full one. 10 frames can be used to support children returning resources and keeping the environment tidy. Why we need that? We needed to do this with the glass pebbles so that they didn't go missing. Use your double-sided counters if you have them. Pause the video while you draw a 10 frame if you need to. Drop the counters onto the table and then fill the 10 frame with the counters. Put the same colour counters together. When you fill the 10 frame, do not count them. Try singing, "This is the way we fill the frame, fill the frame, fill the frame. This is the way we fill the frame," to stop yourself actually counting them. Now draw a picture to represent what you have on the 10 frame and write the calculation. Are there other calculations that can be written from this one representation? Pause the video while you have another go. Use your 10 counters again and drop them onto the table. Draw a new 10 frame or use your 10 frame, then fill the 10 frame with the counters. This time it doesn't matter where you put them. Again, when you fill the frame, don't count the counters using your singing rhyme, "This is the way we fill the frame." Now draw a picture to represent what you have on the 10 frame. Write the calculation. What do you notice? How many different calculations can you find? Use your supertizing skills rather than your counting skills to recognize these different quantities. Pause the video while you have another go. You now have 10 minutes to work with your partner to plan how you could use 10 frames in your classroom. Pause the video while you do so. That brings us to the end of this training. I hope now that you are familiar with the early level progression document and have some ideas about how to use concrete materials effectively in your classes and the sorts of experiences children should be having. We need to remember that learners always need time to explore and play with the concrete materials before we ask them to use for learning.